Alright, so this problem is coming from the Pythagorean Theorem section, so keep in mind when you're doing problems from a section where that's the main topic, try to see how you can make it work for you. So in this case right here, we said that we have the coordinates of the point 5, 10 are going to be 13 units away from the y-axis. So remember, that's the vertical axis. Okay, so it's always good to have some sort of visual to help you out. And I know for me specifically, I really benefit from being able to have that visual. So it's 13 units away. Now, obviously, if I'm talking about this point, 13 units is going to be farther than this distance. So I'm just going to go up here and put a line in. I don't know exactly where it's going to be, but I'm going to go ahead and put that there and something down here, just so I have something to work with, some kind of picture. Okay, but I know that both those are 13, so I'm going to go ahead and label them for their legs. And then it says that we want to go ahead and find what the coordinates of those points are. Well, first we know that they are going to be, they're going to have x coordinates of 0 because they're on the y-axis. So we have that secured. Really, we're just looking for what the y values are. Okay, so there are a whole bunch of different ways to do this thing, but I'm going to go ahead and use just Pythagorean theorem, just like we're studying here. But for this problem, there are no right triangles. So we need right triangles to use Pythagorean theorem. So if you don't have right triangles, look to see how you can bring them in. Okay, so here I have this one big isosceles triangle. Remember, isosceles means that two sides are going to be congruent. But if I draw another line right here, we call this an altitude. Okay, an altitude is going to be a line that goes from a point to the opposite side and is perpendicular to that opposite side. Okay, so we'll get into this stuff later on, but for right now, I've created right triangles. Okay, and now you have to ask yourself, what can I label? What do I know about either one of these right triangles? Well, if you know this is at the coordinate 5, 10, okay, we know that this distance right here, this horizontal distance, is going to be 5 units because it's 5 units out. Okay, so now it's just a matter of trying to find what the base of this triangle, if you want to think about it this way, this vertical piece is going to be for that triangle. So what I'd like to think about here is that I'm going to call it, you can call it whatever you want, but I was going to call it y, but we're talking about y value, so I don't want to get that confused here. So I'm just going to call it a for right now. That distance, the side of that triangle is a. Now, if it helps, one of the things that I have to do is I'll just kind of redraw what I'm actually looking at. Okay, so sometimes it's hard to see because it gets all cluttered in there. I'll just go ahead and label those pieces so it's more familiar to me. Okay, so now I have this thing, and I can see pretty easily that Pythagorean theorem can apply as 5 squared plus a squared equals to 13 squared. Okay. And once I go to simplify that stuff, I have 25 plus a squared equals to 169. Okay. And I'm really just solving for a here, so I'm going to subtract 25 from both sides. And I end up with a squared equals to 144. Okay. Remember, we're solving for a, not a squared, so I take the square root of both sides to get a by itself. So it's a equals to 12. Now, one of the things you need to be careful about here is that for the most part in geometry, it doesn't really matter the piece that I've left off, which is that the square root of a number, when I'm going through it like this, when I have a squared and I take the square root of both sides, anytime I introduce that square root, I need to have that plus or minus here. Okay? But for our purposes right now, having a negative 12 as a distance doesn't make sense. Okay, so often with geometry, you can forget about the plus or minus on accident, and it'll work out for you. But when you get to Algebra 2, that's going to be something that you really need to keep an eye out for. So what I suggest for right now is I would go ahead and just say, okay, just the positive piece. Okay. Now, remember, that's not the end of the problem here, so maybe circling it's not the best idea here. But I'm going to go ahead and just put this as positive 12 for right now. Okay, so, but be aware that it is that plus or minus. Okay, now, for here, I wanted to go ahead and find the coordinates, the y coordinates to actually go with this. Now, if I know that a is 12, I label that in here, it means that this distance from here all the way down to here is going to be 12 units as it is from there to there. Okay, so if I knew that this was already at 10 right here, okay, that means that I'm going 12 up, which means at this point up here, we already know that the x value is 0, so that means that the y value is 12 plus 10, which gives us at 22. Okay. Down here, we know that it's at 10. Here, we go down 12, so we're at 0, negative 12. Okay, and those will be our two answers. So 0, 22, and 0, negative 12. And that's how you work it out. Good luck.